Hello students. In the previous lecture I was discussing about degeneracy in simplex method and I took one problem for that is maximization problem subjected to three inequality constraint equations, and we proceeded till the step of finding the initial basic feasible solution, and we found that after equating the non-basic variable to be 0, we found the basic variables to be positive, so we can apply the simplex method here. Now proceeding in the same way, we'll make the initial simplex table. So in the initial simplex table, the same thing, that is CBI is the cost of basic variable. We have CJ, that is coefficient of objective function. Then we have basic variable column, then solution and ratio. So the next step will be we will write all the variables that are present in the equation, that is x1, x2, s1, s2 and s3. Now we'll write all the coefficients of the variables present in the objective function, that is all the variables, the coefficient of all the variables from the objective function. We'll write all the coefficients. So going back to the modified objective function, we can see the coefficient of x1, x2, s1, s2 and s3 to be 2, 1, 0, 0, 0. So we're going to write all these coefficients, that is 2, 1, 0, 0, 0 with respect to x1, x2, s1, s2 and s3. The next step, as we proceeded in the previous problem also, will fill the basic variable column. We know the basic variables are the newly introduced slack variables. So we will write the newly introduced slack variables in this column, that is S1, S2 and S3, and their coefficients in the objective function. So the coefficient of slack variables in the objective function were 0, 0, 0. So we have written 0, 0, 0 in the CBI column. The next step will be to fill the row corresponding to S1, to fill the row corresponding to S2 and to fill the row corresponding to S3. So as I've told you earlier in the previous problem also, that how we used to fill the row, that we will see in which equality constraint equations, the S1 is present, the slack variable S1 is present, and we will take all the coefficients of that equation and write in the row corresponding to S1. So as you can see, among all the three equality constraint equations, S1 is present in the equation number 1, and the coefficients for this equation for x1, x2 and s1 are 4, 3, 1. Since s2 and s3 are not present, so we'll write their coefficients to be 0, 0. And what is the solution? It is 12. So we have written all the coefficients corresponding to s1 from that equation number 1, that is 4, 3, 1. Since s2 and s3 were not present in the equation, we have written the coefficients to be 0, 0. And here I have not written the solution, but the solution you write it to be 12 for the row corresponding to S1. Similarly, for the row corresponding to S2 and S3, you can fill this row by observing the equations that contains the S2 and S3 slack variables. So for the row corresponding to S2 slack variable, how we will fill the row? The row can be filled from the equation number 2, since the equation number 2 contains the S2 slack variable, and the coefficients are for x1 it is 4, for x2 it is 1, for s1 since there is no s1 it will be 0, for s2 it is 1 and there is no s3 term, so for s3 it is 0 and the solution term is 8. So we'll write all the coefficients for S2, that is 4, 1, 0, 1, 0, and the solution will be 8. I have not written the solution, you'll just write it the solution to be 8. Similarly for S3, it can be obtained from equation number 3, as the equation number 3 contains the slack variable S3 And what are the coefficients? The coefficients of x1 is 4, x2 is -1, s1 and s2 will be 0, 0 since they are not present, and s3 is 1, and the solution is 8. So writing all the coefficients in the row corresponding to S3. Now this is the slide representing the solution, the full row corresponding to S1, S2 and S3. Now next step, what we used to do, we used to find Zj. So for finding the Zj, as I've already told you in the previous slides, so how we used to find the Zj? For finding the first element in the Zj row, what we used to do, we used to multiply the elements of CBI with the column corresponding to this element for which we need to find. So it will be 0 into 4 plus 0 into 4 plus 0 into 4, which will come out to be 0. Again, for finding the second element of Zj row, it will be 0 into 3 plus 0 into 1 plus 0 into -1, which will come out to be 0. In the similar way, we can find all the elements of Zj row. The next step is finding the Cj minus Zj row. Again, how we used to find Cj minus Zj row? Subtracting the elements of Cj row with that of Zj row. So for finding the first element of Cj minus Zj row, it will be 2 minus 0. So it has come out to be 2. Similarly, for finding the second element of Cj minus Zj row, it will be subtraction of this element 1 and the element 0, that is 1 minus 0, 1. In this way, we can find all the elements of Cj minus Zj row. Now I told you that after finding the Cj minus Zj row, if it is of maximization type of problem, to see whether the problem has reached the optimal solution or not, you need to check all the elements whether they are 0 or negative or not. If all the elements are either 0 or negative, then we have reached the optimal solution and we will stop it there. If all the elements are not negative or 0, then we need to proceed further. So since we can see here that all the elements are not 0 or negative, so we will proceed further, and what we will do, we will find the maximum value maximum positive value among all the values of Cj minus Zj row. We will find the maximum positive value. So as you can see, the maximum positive value here, it is 2. So we will encircle the column corresponding to this element. So we have encircled the column corresponding to this element, and this is called key column. Or you can say this variable is the entering variable. Now next step is what we used to do. We used to divide, for finding the ratio, we used to divide the solution with that of the elements of key column. So same thing we will do here also. We will divide the solution column elements with that of entering or key column elements. That is 12 divided by 4 will be 3. So we have written it 3 here. Then 8 divided by 4 is 2. So in the ratio column, the second element is 2. Again, next, the last one is 8 divided by 4, which will come out to be 2. So again, in the ratio column, we will write 2. Now the next step is we need to find the key row. So for finding the key row, what we used to do, we used to find the minimum positive value in the ratio column. Again, I am repeating, we used to find the minimum positive value in the ratio column for finding the key row. Now as you can see, in the ratio column, we have got two minimum values. That is, we have got two values to be same, and they are the minimum values. So here the degeneracy occurs. So these type of LPP problems, this type of linear programming problem, where in the ratio column you get two minimum values and you are not able to decide which one to take the minimum or the key row, which one to assign the key row. So there you can say that the degeneracy has occurred in the linear programming problem. So it is also called tie ratio. So a tie has occurred in the ratio column for the minimum value. Now, how to solve this degeneracy type of problem, I'll explain in the next video lecture. I'm ending this class here.